So in this lesson, we're actually going to use what we've learned about cast rule and reference angles to solve some equations, solve some problems that we maybe haven't looked at before. But before we dive into that, we want to just review some things. So the first thing we want to remember is that a reference angle is actually an acute angle. That's an angle of less than 90 degrees between the terminal arm and the x-axis. So you're going to see in quadrant 1, our reference angle is here. In quadrant 2, it's here. It's between the terminal arm and the x-axis. In quadrant 3, it's down here. And in quadrant 4, it's down there. Remember, that reference angle is always the angle between the terminal arm and the x-axis. There's a couple other things that it talks about in terms of calculating the reference angle, how you do that in each of the quadrants. The other two things we need to remember is we need to remember the cast rule. That helps us remember what's positive in each quadrant. So we have CAST in each of those quadrants telling us cosine, all, sine, and tangent are positive in those particular quadrants. The last thing we need to remember is the ratios for sine, cosine, and tangent are y over r, or x over r, and are y over x. So those are all things you've seen, but you're going to have to use those in this lesson to solve some problems. So if we flip the page and we look at the first problem, it says a point lies at -3 and 2. So it says sketch that. Well, -3, 1, 2, 3, and 2. So that's right about here. So if we draw our right triangle, go down to the x-axis, this distance is -3 and this distance is +2. This is our radius, this is our r value, and we've got to calculate that r value using Pythagorean theorem. So a squared plus b squared equals c squared. Remember, your hypotenuse, the side across from the right angle, is always your c, and our other two sides are -3 squared and our 2 squared are our a and our b. So -3 squared is 9, 2 squared is 4. So this actually gives us 13. And to get r, we have to take the square root of each side. So r is actually the square root of 13. Now it wants us to write our ratios: sine theta, cos theta, and tan theta. So now we can use those values from here. Y is 2, r is root 13. So sine theta is 2 over root 13, but we know mathematicians are anal retentive and they don't like radicals in the denominator, so we have to rationalize the denominator. We have to multiply by root 13 over root 13, and to get 2 root 13 over 13, just like we did in the last unit in radicals. X over r is going to give us, for cosine, -3 over root 13. And again, we need to multiply by root 13 over root 13 to rationalize the denominator. So we get -3 root 13 over 13. And if we do y over x, we get 2 over -3, or -2/3 for tangent in this case. Second example says we have a terminal arm at -4 and -2. So we're going to draw a picture. 1, 2, 3, 4, 1, 2. So we have a point right about here. There's our terminal arm. There's our right triangle. So we're working with this angle theta. So this is a distance of -4 and this is -2. So we have to find r. So we're going to get -4 squared plus -2 squared equals r squared. This is going to give us 16 plus 4 is r squared. So this is going to give us the square root of 20 for r. So now it asks us to actually find the exact value of sine. Well, sine is y over r. So that's -2 over root 20. But we have to rationalize our denominator. We have to multiply by root 20 over root 20. So we get -2 root 20 over 20. One problem we have is root 20 is not in simplest form. We need to simplify that. That's the square root of 4 times the square root of 5. Well, the square root of 4 is 2. 2 times negative 2 is going to give us negative 4 root 5 over 20. We can then also divide here. We can divide this by 4 and that by 4, and that ends up leaving us with negative root 5 over 5 with our radical in simplified form. All right, sometimes instead of giving us a point, what they give us as information is they tell us the quadrant we're in and they tell us one of our ratios. So we can use that to sketch a diagram. Tells us we're in the third quadrant. So we're in the third quadrant. So we're going to draw a right triangle here. It says sine is negative 4/5. Now they put this negative in the middle. I usually like to write the negative in the numerator. Always keep it in the numerator. Now, sine is y over r. So the y value is negative 4 and the r value is 5. So now we need to find our x value in this case. So we're going to use Pythagorean theorem. We're going to use x squared plus y squared equals r squared. We know r is 5. We know y is negative 4, and we're solving for x. So we get x squared plus 16 equals 25. If you subtract 16 from each side, you end up with x squared being 9. So x is 3. But if you look at this, the x coordinate is actually on the negative x-axis, so x needs to be negative 3 in this case. So they want us to actually find cosine and tangent here. So cosine is x over r. We've just calculated x to be negative 3 and r is 5. Tangent is y over x, and we find out that y is negative 4 and x is negative 3. So when you simplify that, you actually get 4/3. Okay. We're going to do a similar example. In this next example, it says tangent is negative 2/3 and cosine is positive. Okay, so we need to draw a coordinate plane and we need to put the cast rule in here. Now, it says tangent's negative. Well, tangent's negative in quadrant 2 and quadrant 4. And it says cosine is positive. Well, the only quadrant where cosine is positive and tangent is negative is down here in quadrant number 4. Next, it says this is negative 2/3. So we have to look at that fraction. We have to look at that 2/3 in the fourth quadrant, and we have to decide what's positive and what's negative. Remember, this is y over x. Well, we're going down on the y-axis, so that means the 2 has to be negative. And we're on the positive x-axis, so that means the 3 has to be positive. We then have to find our r. We have to use Pythagorean theorem. So we're going to get 3 squared plus negative 2 squared equals r squared. This is 9 plus 4 is r squared. That means r is going to be the square root of 13. And it says find the exact value of sine. Well, sine is y over r. The y value is negative 2, the r value is root 13, and then we need to rationalize the denominator by multiplying by root 13 over root 13, and we get negative 2 root 13 all over 13. And there we go. So we've looked at how to use reference angles and how to use cast rule to determine different values of sine, cosine, and tangent in different quadrants.